Hey people, Mr. Trutna up in the clouds. This is Unit 2, Assignment number 1, Notes. Go ahead and take accurate, precise notes on these problems. So the first part is congruent statements. So let's say that I have two triangles. And the two triangles look like that. You've already been given one of the triangles, and I'm going to hand draw the other triangle. And you can see that one of them is upside down of the other one. And let's go ahead and name the vertices of the triangle on the left as NFL. Sorry, Raider fans, you're 0-2. And let's name the other triangle MLB. Sorry, Giant fans, you're out of the playoffs this year. In angle NFL, let's go ahead and mark angle N as having a measurement of 52 degrees. Let's mark angle F as having a measurement of 68 degrees. So that means if I did the math and I added these two up, 68 plus 52 is 120. And because the three angles in a triangle are always 180 degrees, if I take away 120 from 180, that means that the third angle, L, is 60 degrees. Okay, then let's go over here and let's mark angle L as 60 degrees. Let's mark angle B as 68 degrees. And let's mark angle M as 52 degrees. Okay, let's add a little bit more. Let's mark side N to L as having a length of 15 units. Let's mark side F to N as having a length of 12 units. And then let's mark side F to L as having a length of 9 units. And then let's go over here and let's match up. So that would mean that let's mark side M to L as 15. Side B to M as 12, or M to B as 12, and side B to L, or side L to B, as being 9. Okay, so because these two triangles have all the angles in the triangles are equal, and because all the sides in the triangles are equal, we could say that these two triangles are congruent with one another. Okay? Notice that we can see that angle F is the same or congruent with angle B. Also, angle N, which is 52 degrees, is congruent with angle M, which is also 52 degrees. And notice that angle L, which is 60 degrees, is congruent with the other angle L, which is also 60 degrees. Okay? You know what? I'm going to go ahead and I'm going to change this L over here in that triangle to a different letter so we don't match up letters or repeat letters, I guess. Let's go ahead and call this Z right here. So that means that angle L, which is 60 degrees, is congruent to angle Z, which is 60 degrees. Sorry about that mistake there. I didn't realize I had repeated letters. Also, we know that side F to N, which has a length of 12, is congruent to side B to M, which also has a length of 12. Okay. Side L to N, which has a length of 15, is congruent to the side of this triangle over here, which has a length of 15, which has the Z and the M in it, and I would have to write it as ZM. Notice what I'm doing. If I started with L, L's right at the 60 degrees, so I have to start at Z, which is at 60 degrees also. So I'm always matching up the letters that I have with each other. And also notice that side F to L, which has a length of 9, is going to be congruent to the side over here, which has a length of 9, which is B to Z, or Z to B, and I would have to write it as B to Z, because I'm always putting the letters in the same order, okay? So whenever two triangles, whenever all three of the angles are congruent with each other, and all three of the sides are congruent with each other, this means that the two shapes are congruent. So remember the equal sign with the squiggle, that is the mathematical symbol for the word congruent. And congruent means that all corresponding parts are the same. Okay, are the same. Now, whenever you know that two shapes are congruent with each other, in this case these two triangles are congruent with each other, then we could write what is known as a congruent statement. Okay, and a congruent statement is this. So what we're going to do is we're going to go over to this triangle on the left, and we are going to name this triangle using the three letters F, N, and L in any order that I want. And I'm going to refer to it as triangle FLN, and then I'm going to put the congruent symbol, and then I'm going to finish off the statement by appropriately matching up the letters. So if you notice that F in the triangle on the left, which is 68 degrees in the other triangle is B. So because I put F first, that means I have to put B first in the other triangle. I'm matching up the letters in the same order. Because I put L second, and because L is 60 degrees, the 60 degree in the other triangle is Z, so I would have to put Z second. And then because I put N third, and N is 52 degrees, and the 52 degree angle is M, I would have to put M third. So my congruent statement for this, for these two triangles would be a statement that matches up the letters in the correct order that I can use whenever two shapes are congruent with each other. Okay, so this would be an example of a congruent statement. Right here, triangle FLN is congruent with triangle BZM. And the order that I write those, that B, the Z, the M, is very important. Okay, now, mathematicians were very interested in shapes that were congruent with each other. It had a lot to do with architecture, and then because it had a lot to do with architecture, mathematicians were very, very interested in triangles. And how do you know that one triangle is congruent to another triangle? Okay, and these are what are known as the triangle congruence theorems. And what mathematicians found out is they found out that there are 5 theorems that prove one triangle is congruent to another triangle. Okay, here is the first theorem right here. So let's say the left sides of the triangles are equal to each other. Let's say the bottom of the triangles are equal to each other. And let's say the right side of each of the two triangles are equal to each other as indicated by these congruent marks. Okay, and let's go ahead and label the corners or the vertices of the triangle on the left as ABC and the triangle on the right as XYZ. Okay, so what mathematicians found out was that even though we don't know anything about the angles in any of the triangle, in either one of these triangles, notice I don't have any measurements of these two triangles. What they found out was that they would know for a fact that triangle ABC would be congruent with triangle XYZ. And this is an example of what they call the side rule. Okay, So in this first example, those two triangles right there would be congruent because of the side rule. And the side rule says if three sides of one triangle are congruent to three sides of another triangle, then the triangles have to be congruent. Okay? And there were four other, total of 5 rules that mathematicians found out that prove two triangles are congruent, even if you don't know all the parts of the triangles. Okay? The second rule would be, and here's an example of the second rule. And notice in this second rule, we have a pair of sides that are equal. We have a second pair of sides that are equal, but we don't know if the bottom sides are equal. But we have a pair of angles that are equal to each other in each one of the two triangles. Okay, so this rule right here is what is known as the side angle side rule. These two triangles would be congruent because of the side angle side rule. Okay, what does the side angle side rule say? It says that you have to have two pairs of congruent sides. That's what the S's stand for. Two pairs of congruent sides, and you have to have one pair of angles that are congruent, and the pair of angles that are congruent have to be in between or included between the two sides that are marked as congruent to each other. So that would be side, side, side. Okay. The third rule out of 5 would be a rule like this, and I'm going to mark it. So let's say the top angles are equal to each other, and I'm going to color those in as yellow. And let's say that the bottom right angles are equal to each other. And I'm going to color those angles in. The inside of those angles is blue. So those two angles are equal to each other. And then let's say the right side of each of the triangles are congruent to each other. And I'll highlight those sides in green there. So you can see in this one, we have a pair of congruent angles. Those are yellow. We have a second pair of congruent angles, those are blue, and then we have a pair of congruent sides, which is green. Mathematicians found out that these two triangles would have to be congruent to each other, and this is an example of what is known as the angle side angle rule. So the angle side angle rule says that two triangles are going to be congruent to each other if you know that two of the pairs of the angles are equal to each other. We've got the yellow and the blue angles are equal to each other. And there's a pair of sides that are equal to each other. And the pair of sides that are congruent to each other or equal to each other have to be in between the two angles that are equal to each other. And we say that side is what is called an included side. So the congruent sides have to be included between the congruent angles. Okay. Another way that mathematicians found out why two triangles are congruent is, let's say these bottom left angles are congruent to each other. I'm going to indicate that. I'm going to color those in with my yellow highlighter. Then let's say that the top angles are congruent to each other. So you can see right now we have two pairs of congruent angles. That second pair I'm going to color in blue. And then let's say that there's a pair of sides that are equal to each other. Like let's go with these bottom sides, and I'm going to highlight those sides in green here. But if you notice, unlike angle side angle, the sides that are congruent are not included in between the congruent angles. So this is what mathematicians called the angle side rule. And mathematicians found out that these two triangles, if they have two pairs of congruent angles, the yellow and the blue, and a pair of congruent sides, and even if the side is not in between the two angles, these two triangles would still have to be congruent because of the angle side rule. Okay, so these are the 4 rules that work for any triangle. So we got side, side, side. We've got side, angle, side. We've got angle, side, angle. We've got angle, angle, side. Those are what are known as the triangle congruence theorems. And then there's a fifth theorem, which is specific only to right triangles. Okay? So let's say in these, and here's how this fifth theorem works. Let's say in these right triangles, let's say those two sides are marked as equal to each other. So these two sides that I highlighted in yellow are equal to each other. And by the way, those two sides are called the hypotenuses. You may not have remembered that, but each one of those sides is what is known as the hypotenuse. And the hypotenuse, remember, it's always the longest side in a right triangle. It only shows up in a right triangle. It's always the longest side. And then let's say that one of the other sides is congruent. Like let's say this left side is marked as congruent to the other left side, and I'm highlighting those sides in blue. Okay, so this rule is what they call these two triangles would be congruent, and the rule that they call it is the hypotenuse leg rule. And this hypotenuse leg rule it's specific to only right triangles. So what does it say? The hypotenuse leg rule says the hypotenuses of the right triangles are equal to each other, and then one pair of the legs, and those are the blue ones, are equal to each other. But you don't know anything about that second pair of legs, okay? So the triangle congruence theorems are theorems that prove two triangles are congruent, and mathematicians found out that there are 5 different theorems on how you can prove triangles are congruent to each other. Okay? All right, then let's go to the last thing, which is really a review. How do you find the area of a trapezoid? So if you remember, a trapezoid is a 4-sided shape. The sides of the 4-sided shape could be equal or they could be not equal. But the thing is, in a trapezoid, it's always going to have just one pair of parallel sides. So you can see in this drawing, I have a 4-sided shape. The top is parallel to the bottom. That's what those arrows indicate. So that would be, this is what a trapezoid looks like. Okay. Now let's go ahead and mark the bottom of having a length of 20. Let's go ahead and mark the entire top as having a length of 14. And then let's draw a dotted line from the top left corner straight down to the bottom of the trapezoid, and let's put that it makes a 90-degree angle. Okay, now this line right here is what is known as the height of the trapezoid. All right, now the height of a shape always goes from the highest point, anywhere of the highest point of the shape, down to the bottom or the base of the shape, but it has to make a 90-degree angle where it touches. So for instance, if I drew in this line right here, that line right there, that dotted line, that's also a height. If I went over to the right corner here and I went straight down to the base, so it made a 90-degree angle, all 3 of those dotted lines would be representations of the height of the trapezoid. And let's say that the height of the trapezoid was 6 units long. Okay, so here's how you find the area of a trapezoid. There's a formula that you use in order to find the area of a trapezoid. And it's probably best if you remember this formula. Okay, so the formula is you take however long the bottom base is, you add it to however long what they call the top base is. And it's kind of weird that in a trapezoid, you refer to it as having 2 bases. But if you think about it, if I took this trapezoid and I flipped it over, reflected it over, I could still stand up the trapezoid on the top. Okay? Then you multiply that with however long or however the height of the trapezoid. Okay? And then you divide all of that, whatever that equals, bottom base plus top base, multiplied with the height, you divide it all by 2. Okay, so it's bottom base plus top base in parentheses, so you do that first. You multiply it with the height, and then you divide it by 2. That's how you find the area of a trapezoid. So finding the area of this trapezoid, I would take the bottom base, which has a length of 20. Then I would add it to the length of the top base, which has a length of 14. And then after I do that, I would then multiply that with the height of the trapezoid, which is 6. So I'd multiply it with 6. And then after I work all of that out, I would divide it all by 2. Okay? So top base plus the bottom base, then you multiply it with the height, and then we're going to divide it all by 2 here. Okay? So let's go ahead and work this out following the order of operations. So I'm going to go 20 plus 14, which is 34. So I'm going to multiply 34 with 6, and then I'm going to divide it all by 2. Multiplying 34 with 6, that's 204. And then I'm going to divide 204 by 2. So that would give me an area of 102 would be my area for this trapezoid. Okay, so there we go. Find the area of a trapezoid. We got this formula here. We know the 5 congruence theorems on how to prove one triangle is congruent to another triangle. And then we went over that when 2 triangles are congruent with each other, we could always write out a congruence statement, which is a statement that accurately corresponds each one of the pieces or letters or angles or sides of the triangle.